Okay, so now let's graph quadratic equations in two variables. All right, so by now you guys know what a quadratic equation looks like, right? It's got an x squared term. It may or may not have these terms here, but remember that x squared term does not have 0 in front of it, otherwise the x squared wouldn't be there, okay? And so it'll look something like this. It may or may not have these two pieces right here, though. Okay, so let's graph this thing. I would probably start off by making a table, if I can write. All right, so if I put in 0 for x, 0 squared is 0. 0 minus 1 is negative 1. Okay, if I put in 1 for x, we've got 1 squared minus 1, which gives us 0. If I put in 2 for x, then I have 2 squared minus 1, which would be 3. Okay, and I always like to do some negative numbers too, but this you have to be really careful about. If you put in negative 1, you've got to make sure that you do that. Okay, so negative or 1 squared is positive 1. Positive 1 minus 1 is 0. And if I put in negative 2, I get negative 2 to the second power minus 1, which is 4 minus 1, which is 3. All right, so let's graph these points here. So negative 2, 3 is right here. Negative 1, 0 is right here. 0, negative 1 is right here. 1, 0, right here. And then 2, 3 is right here. Okay, now this is a very, very rounded shape. Okay, so it kind of looks like it goes into a V, but it will not be a sharp V. It'll be a very rounded V or a U. Okay, so it'll look something like that. The other thing that I want to make sure that you guys do, make sure that you put your arrows at the end. This continues going up and 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 up forever. All right, so make sure you use arrows on the ends of your shapes. So I want to compare these two equations to you. Notice this one has an x squared term, so it's a quadratic. It just doesn't have the x to the first power and it doesn't have the constant term. This is also a quadratic. It just doesn't have the x to the first power term, and that's okay. All right, this is the one that we did last time. So I'm just going to rewrite what we got there. Let's see here. Okay, so that was our table that we got from the last page. Now let's go ahead and do the same table here. And let's do the same x values. And let's see what happens. So whenever we square negative 2, we get out 4. Whenever we square negative 1, we get out 1. Whenever we square 0, we get out 0. Whenever we square 1, we get out 1. And whenever we square 2, we get out 4. All right, let's do this one in red, okay? So we're graphing x squared in red. Negative 2, 4 is right here. Negative 1, 1 is right there. 0, 0 is the origin. 1, 1 is right here. And 2, 4 is right there. Okay, so this graph looks like this. I don't know why, but I have a tough time hitting those points sometimes. All right, so we're going to do this one in purple. All right, so let's see here. Negative 2, 3 is right here. Negative 1, 0 is right here. 0, negative 1 is right here. 1, 0 right there. And then 2, 3 is right here. Notice that each point is lowered by 1, right? Every single, let me see here. So every single x value, this number over here is lowered by 1. Every single x value, this number over here is lowered by 1. Notice this, it went down 1. This went down 1. This went down 1. Okay? So can you maybe deduce here that this minus 1 has something to do with it? It sure does. All right, so this page just kind of tells you how the parabola opens up. So if your leading coefficient, the number that is in front of your x squared term, if it is positive, it will open upwards. If that number is negative, it will open downwards. All right, so on this, we're just looking to see whether it opens upward or downward. So let's see here. On A, look at your leading coefficient, the term that is the coefficient that's in front of your x squared. This is negative, so on A, this will open downward. On part B, looking at this number that's in front of the x squared, it's positive, so it will open upward. Okay, so one of my favorite things about quadratics is that there is something called an axis of symmetry. And I know that it kind of sounds like a difficult concept, but it actually isn't. It is the thing that makes your life 50% easier whenever you're graphing these things, okay? So, first of all, write this down. You know that I've always told you whenever you needed to have something in your notes, and this is something you need to have in your notes, okay? So, your axis of symmetry for a parabola is the line of x is equal to negative b over 2a, okay? Just write it down, and I'll show you what it means here in just a second. Okay, so the vertex, the x-coordinate is the same thing, okay? So the x-coordinate will be at negative b over 2a, and then your y-coordinate will be whatever you get whenever you substitute this in for the x. And again, I'm going to show you what that means here in just a second. Okay, the other thing I want you to remember right here, this is a vertical line. Notice there's no y in that equation, okay? So this is going to be a vertical line. And again, I'm going to show you what all this means. So all I'm asking you to do is write this down, write down this sentence, and write down this sentence. You might want to hit pause here. All right, so we are going to find on part A the axis of symmetry for this equation, and then we're also going to find the vertex, okay? So the axis of symmetry is when x is equal to negative b over 2a. Your a is 3, your b is negative 6, and your c is 2. We're not even going to be using c in this case, okay? So negative b, our b is negative 6, so remember negative b means the opposite of that. So I want positive 6 over 2 times 3, which is 1. So our axis of symmetry is at x equals 1. So if we had a graph, we usually do our axis of symmetry as a dotted line. So it would be about right there. Okay, remember, x equals 1 is a vertical line. All right, so that's for part A. Our axis of symmetry is x equals 1. All right, on B, we are looking for the vertex, okay? We already found the x-coordinate of the vertex. It's 1, okay? Whenever you find your axis of symmetry, you have found your x-coordinate of your vertex. All right? Your y-coordinate is what you get when you substitute in 1 for x, okay? So we're going to do y is equal to 3 times 1 squared minus 6 times 1 plus 2. So y is equal to 3 times 1, which is 3, minus 6 plus 2. Now we've got to do this first. Okay, so our vertex is at 1, negative 1. Okay, so we will find the intercepts of a parabola the same way that we have always found our intercepts, okay? To find your y-intercept, you let x equal 0 and you solve for y. That's usually the easiest one to find, okay? Usually. To find your x-intercept, you let y equal 0 and you solve for x. Now, to do this one over here, you might have to either factor, you might have to use completing the square, or you might have to use the quadratic equation, which is why I say that this one is usually easier to find. All right, so for this problem, they want us to find the intercepts, okay? So let's see here. To find the y-intercept, I'm just going to abbreviate there. I'm going to let x equal 0, okay? This one's our easier one to find, okay? So I'm going to put 0 in where I see the x's. Y is equal to 0 squared minus 2 times 0 minus 8. Well, that creates 0, that creates 0, so I'm left with y is equal to negative 8. So my y-intercept is at 0, negative 8. All right, so to find the x-intercepts, let y equal 0. So I'm going to put in 0 where I see y. All right, let's see if we can factor this. I think we can. Okay, so now I'm going to take each of those factors and I'm going to set them equal to 0 and I'm going to solve. All right, so our y-intercepts are at, our x-intercepts, please excuse that. X-intercepts, that's what we're finding here. 4, 0, and negative 2, 0. So notice, here's one thing I want you to notice. Notice we only get one y-intercept, okay? But notice here you get 2 x-intercepts. That's okay. That's because of the shape, okay? And we know some things about this. We know 3 points that lie on this graph, so that gives us a lot of information about this point, about this graph, okay? And I'm going to show you here in just a second. We're going to put all of this together. We're going to use our axis of symmetry. We're going to use our vertex. We're going to use our y-intercepts. I'm going to show you that it's actually not that bad to graph a quadratic. All right, so this page just kind of shows you, remember this thing right here? Do you remember that? Do you remember what it's called? The discriminant. Do you remember the discriminant? Okay, so this shows you, remember whenever our discriminant was greater than 0, we actually got 2 solutions. Notice it crosses the x-axis in 2 places, there and there. Okay, when our discriminant is 0, there's only 1 solution. That means it bounces off the x-axis in 1 spot, okay? And when our discriminant was less than 0, remember we can't take the square root of a negative number, so that means that we got no real solutions and there are no x-intercepts because notice this thing does not ever cross that x-axis. All right, so let's find the intercepts of the parabola. Now notice it doesn't say find the x-intercept and it doesn't say find the y-intercept. It says find the intercepts. That means you need to find all of the intercepts, the x and the y. So to find the y-intercept, we let x equal 0, okay? So that's the first thing we're going to do. We're going to let x equal 0. So we've got y is equal to 5 times 0 squared plus 0 plus 4. So that's 0, and we're left with y is equal to 4. So our y-intercept is at 0, 4. Okay? Now to find the x-intercept, intercepts, if there's more than one, there could only be one, or there may be none. We have to see. Let y equal 0. Okay, so we've got 0 is equal to 5x squared plus x plus 4. Okay, so let's see here. I don't think it's factorable, so we will just use the quadratic formula. By the way, our A is 5, our B is positive 1, and our C is 4. So we've got negative 1 plus or minus 1 squared minus 4 times 5 times 4 all over 2 times 5. Okay, so let's do some math here. All right, so x is equal to, We've got -1 plus or minus, don't know what that is yet, over 10. So on my calculator, I am typing in 1 squared minus 4 times 5 times 4. And I get -79. I can't take the square root of a negative number, so that means that we must have one of those situations on the graph. So it must look like, let's see here, it'll look something like 1, 2, 3, 4. It'll go through that point right there, but I don't know which side it's on, so I'm just going to make something up, okay? But it looks something like that. That means there are no x-intercepts. There are none, okay? So we do have a y-intercept, but we have no x-intercepts, okay? And without a little bit more information, we don't really know what the vertex is. We didn't even find it. All we had to do was find the intercepts, okay? But we could find the vertex of this thing. You remember -b over 2a. I'm not going to worry about it because it didn't ask us to graph it. So just know that this graph may not match this equation. I was just giving you a for example, but it definitely does not cross the x-axis. All right, so let's take a look at this one. Again, find the intercept. So that means we need to find the y-intercept, and we also need to find the x-intercepts if there's more than one, or if there's even one. All right, so let's do that. Okay, so again, to find the y-intercept, we let x equals 0, okay? So we've got that y is equal to 4 times 0 squared minus 12 times 0 plus 9. So this creates 0, this creates 0. We are left with just 9. So our y-intercept is at 0, 9. Okay, that one's always the easy one to find. Okay, so now we're going to let y equal 0, and we're going to solve for the x-intercepts, okay? So 0 is equal to 4x squared minus 12x plus 9. Our a is 4, our b is -12, and our c is 9. I'm not even going to try to factor this. I don't think it's factorable. I didn't really think long and hard about it, but I just want to practice using the quadratic formula with you. So again, if it is factorable, that's always something you can do, but let's just use the quadratic formula. By the way, if you ever don't want to factor, the quadratic formula will find your answers for you too. So, all right, so x is equal to -b. That means the opposite of our b term. So that is +12 plus or minus -12. Got to use those parentheses here. Squared minus 4 times a times c all over 2 times a. Okay? All right, so now I've got x is equal to 12 plus or minus the square root of, don't know what that is yet, over 8. So on my calculator, parentheses are super duper important because of that negative sign. So parenthesis, -12. I'm going to close my parenthesis, and then I'm going to hit my square button, minus 4, open parenthesis 4, close parenthesis, open parenthesis 9, close my parenthesis, hit enter, and I get 0. That means that we will only get one x-intercept, okay? Because remember, you can only take the square root of 0 one way. So we end up with x is equal to 12 plus 0, which doesn't change anything, or 12 minus 0, which again doesn't change anything, over 8, which ends up being 3 over 2. And so our x-intercept is at 3/2 and 0. You could also say 1 1/2 there, but I like 3/2 just as well. All right, that's it for this problem. Okay, so now let's kind of pull everything together and let's graph this thing using all of the things that we know about quadratic equations, okay? So the first thing, if we want to graph a quadratic equation, first thing I want to do is I want to find where the vertex is, okay? So the vertex is at negative b over 2a. Okay, and where do we get the a, b, and c from? Well, first of all, make sure this is in standard form, and it is. Our a in this case is 1, our b is negative 6, and our c is positive 8. Okay, so our vertex, the x-coordinate of our vertex is at positive 6. Remember, negative b means the opposite of whatever the b is. 2 times a. So 6 divided by 2 is 3. So our x-coordinate is at 3. So I've got to find the y. So y is equal to 3 squared minus 6 times 3 plus 8. So I've got 9 minus 18 plus 8. This is negative 9 plus 8. So it's at, our y-coordinate is at negative 1. Okay, so our vertex is at 3, 1. Sorry, negative 1. There we go. 3, negative 1. Okay, so I'm going to go over here to the graph, and I'm going to go over here to 3, negative 1, and I'm going to put a dot. Now, I know that this thing will open upward, so it'll be one of those types rather than one of those types, okay? The reason why I know that it will open upward is because the leading coefficient here is positive. Okay, so that means that it will open upward. So I know that if I get something that opens downward, that I've messed something up somewhere, okay? All right, so the next thing I want to do is let's find our intercepts. Okay, so to find my y-intercept, I'm going to let x equal 0, okay? So y is equal to 0 squared, let's see here, minus 6 times 0 plus 8. That means that goes away, and I'm left with y is equal to 8. So I have a y-intercept at 0, 8. So I can go up here to 0, 8 and put a dot. Now, do you remember us talking about the axis of symmetry? And remember, that axis of symmetry is a vertical line that goes through the vertex. Okay, so check this out. The axis of symmetry is, and I'm just going to make it a dotted line, and we're going to pretend, because Stacy doesn't know how to draw a straight line, we're going to pretend like that's a straight line. So there's my axis of symmetry. Okay, now what the axis of symmetry does is it creates a situation where the left side is identical to the right side. So notice this point right here where our y-intercept is. It is 1, 2, 3 to the left of the axis of symmetry. That means that we actually have a point that is 3 to the right of the axis of symmetry. So because of the axis of symmetry, I am allowed to put another dot right there. Okay, let me erase these other two little lines that I made. Okay, so the axis of symmetry helps me find another point. All right, so now let's find the x-intercepts. All right, so we're going to let y equal 0 now, okay? So 0 is equal to x squared minus 6x plus 8. And this I can factor. I know it right off the top of my head. It's x minus 2 and x minus 4. They multiply to be positive 8, but they add up to be 6, or negative 6, sorry. So then I've got, so x is equal to positive 2 and x is equal to positive 4. So I have x-intercepts at 2, 0 and 4, 0. Okay. So let's see here. 2, 0 is right here. 4, 0 is right here. Thank goodness, because if that wasn't exactly equidistant away from the axis of symmetry, I would have been really nervous. Okay, I would have known that I did some math wrong here. Okay, so luckily our axis of symmetry is right here. We had one dot to the left of that. We have one dot to the right of that. Okay, so that means that I actually have enough information here to finish this quadratic or this parabola. Okay, so I'm going to just draw my lines here, or line. There we go. That's it. So we used everything that we knew about quadratics in this one problem. We found our vertex. We found our y-intercept, and because of the axis of symmetry, we found another point that isn't an intercept. It just happens to be a great place to put a dot. And we found our x-intercepts, and they helped us finish this graph off too. All right, so these are all things that we did. We may not have done this in the exact same order, but the order doesn't necessarily matter. We end up with the same end product. So again, it might be something that you refer back to, but you don't necessarily have to memorize this or have this in your notes. All right, so let's do the same thing on this one. Now, before we even try to graph this, let's take a look at some things that we know about this information right here. This quadratic equation, we know that it will be a parabola, which means it's a U-shaped figure. And because this leading coefficient is negative, I know that it's going to be upside down. Okay, so it's always a good idea to have that thought in your head of what the shape will look like before you start to graph it. Because in case you make any mathematical mistakes, you know that you made the mistake. You may not know how to fix it, but you know that you've made the mistake and you know that you need to fix it. Okay, all right, so the first thing I want to do is I want to find the vertex. So the x-coordinate of the vertex is going to be negative b over 2a. Well, a is negative 1, b is positive 6, and c is negative 9, okay? So let's go ahead and do this math. The opposite of b is negative 6, 2 times negative 1 in the denominator, okay? So I get negative 6 over negative 2, which gives me positive 3. That's just our x-coordinate. So let's find our y-coordinate of the vertex. So y is equal to negative 3 squared plus 6 times 3 minus 9. So you do this math first. 3 squared is 9. 9 times a negative is negative 9. So negative 9 plus 18. Now we go in order from left to right. We get 9 minus 9, which gives us 0. So our y-coordinate is 0. So our vertex is at 3, 0. Which is right here. Now, we also know that the axis of symmetry goes through the vertex, okay? So I'm just going to draw the dotted line that is the axis of symmetry. Okay, so on that line, everything to the left of that line should be identical to everything to the right of that line, okay? All right, so now let's find our y-intercept. We're going to let x equal 0. So we've got y is equal to so this goes away, and I'm left with negative 9. Okay, so my y-intercept is at 0, negative 9. So I'm going to put a dot here at 0, negative 9, which is down here. All right, now because of the axis of symmetry, I know that if I go 3 to the left of this line and put a dot, I can go 3 to the right and put a dot too, okay? So it would be right there, okay? And we know that because of the axis of symmetry, okay? All right, so now it may not help us to find the the x-intercepts. And why do I know that? Because notice that my x-intercept, there's only one of them because that's where my vertex is, okay? But I do need at least one other point, so I would probably put 2 in and just do the math so that I can get another point, okay? Because I definitely want at least one other point so that I could graph this thing a little bit better. Okay, so I'm going to put in x as 2, and I just pulled that number out of the air. I could have put in x as 1, and that actually might just be easier. It doesn't matter. We could do both if you want. So let's do let x equal 1. How about that? So we've got y is equal to y is equal to -1 plus 6 minus 9. -1 plus 6 is 5. 5 minus 9 is -4. So whenever x is 1, y is -4. So let's go put a dot at 1, -4, which is right here. Now remember, because of the axis of symmetry, if I go 2 to the left of that line and put a dot, I can go 2 to the right and put a dot, okay? So there's a dot right there. Now, just for the sake of finishing this graph, let's let x equal 2 now. So I'm going to put 2 in and do the math. All right, so 2 squared is 4. 4 times a negative is -4. Okay, so -4 plus 12 is 8, which is -1. So when x is 2, y is -1. So I have a point at 2, -1, which is right here. And again, thanks to the axis of symmetry, if I go 1 to the left of that and put a dot, that means I can go 1 to the right and put a dot there too. There we go. Now we have a great picture of this parabola. There we go. That is our parabola right there. It's kind of a pretty one. Gotta say, I'm a little proud of that parabola. All right, let's graph this one. Okay, so again, first thing I want to do is I want to find my vertex. Okay, so the x-coordinate of my vertex is -b over 2a. So my a is 1, my b is 4, and my c is 5. Okay, so opposite of b is -4 over 2 times 1. So that's -4 over 2, which is -2. Okay, so that's my x-coordinate. Now, let's substitute -2 into our equation and see what we get out for y. Got to put parentheses around that. So this is 4, positive 4. So you get that y is equal to 4 minus 8. Why did that change to a minus? Because I have a positive times a negative. So that's why that changed to a -8 there. And now go in order from left to right. So that's -4 plus 5, which is 1. So our vertex is at -2, 1. Okay, so I'm going to go over here to -2, 1, and put a dot. Now, I also know that my axis of symmetry goes through that point. Okay, so it's the vertical line that goes through that point. It's always good to draw that axis of symmetry. Okay? All right. Now, what do I know about this? I know that this parabola opens upward. How do I know that it opens upward? Well, I know it because the leading coefficient is positive, okay? So notice if this thing opens upward, and this is the absolute lowest point that it could be, that means it's never ever going to cross that x-axis, okay? So we will never have x-intercepts on this graph. What does that mean? That means our discriminant is a negative number, okay? So I don't even have to do that math. I know that it's going to be a negative number because I know that this shape opens upward. This is the lowest point. The lowest it can go is +1, so it can't even go down to 0. Okay, I'm not even going to do the math to try to find the discriminant because it's a waste of my time. All right, it's a waste of your time too. All right, but I can find my y-intercept. If this thing opens upward, it's definitely going to cross that y-axis at some point. So let's find that. We're going to let x equal 0 here, okay? So I've got that y is equal to 0 squared plus 4 times 0 plus 5. So that means that goes away, that goes away. I am left with y is equal to 5. So 0, 5 is a point on this graph, which is right there. Now remember, thanks to the axis of symmetry, I know that if I go 2 to the right and put a dot, I can also go 2 to the left and put a dot. So that's what we're going to do. All right. Now, again, not even going to do me any good to find the x-intercepts because there aren't any. Okay, but what I can do is I could let x equal -1 and see where that other point is, or if I wanted, I could let x equal 1 and see it's got to be up here somewhere. It doesn't matter, really. You can put in whatever value you want for x. So I'm going to let x equal -1. Let's see what we get out for y. Okay, so -1 squared is +1. And then -4, don't forget a positive times a negative. So 1 minus 4 is -3. So y is equal to 2. Okay, so -1, 2 is a point on our graph. -1, 2 is right here. Okay, and that means that I also have a point right here thanks to the axis of symmetry. All right, and if you want, you could put in x is equal to +1 and find some other point that's probably up here somewhere, or you can just go ahead and draw your graph. All right, there you go. There's our graph. Looks pretty nice. All right, let's do another one. Okay, so again, the first thing we want is we want our vertex, okay? So we want our A, our B, and our C. A is 2, B is -4, and C is -3. Okay, so let's see here. Our x-coordinate of our vertex is -b over 2a. So that would be 4 over 2 times 2, which is 4 over 4, which is 1. Okay, so our x-coordinate is 1. Let's find our y-coordinate. So 1 squared is 1, times 2 is 2. Now let's do that. So y is equal to -2 minus 3, which is -5. So our vertex is at 1, -5. All right, let's draw that vertex. 1, -5 is right here. That also means that our axis of symmetry goes through that point. All right, there's our axis of symmetry right there. Okay, now let's find our y-intercept. So we're going to let x equal 0, right? So we've got y is equal to 2 times 0 squared minus 4 times 0 minus 3. That creates 0, that creates 0. We now have that y is equal to -3. So we have a point at 0, -3. So let's put that on the graph. Okay, so that means that thanks to the axis of symmetry, I've also got a point right here. Okay, all right. Now, does this thing go through the x-intercepts? It totally looks like it does, yes, because we know that it opens upwards because that's a positive number, so it goes like this. So it's definitely going to cross that x-axis in 2 places. So I don't think it'll factor though, so that's going to be a problem. Not really, but okay. we're going to use our A, B, and our C, and we're going to use the quadratic formula. All right, let's do some math. All right, now on my calculator, I'm going to do what's under the radical. I have to use parentheses here because that's a negative number. So I have parenthesis, -4, close the parenthesis, hit the square button. Minus 4 times 2 times -3 equals 40. Okay, now I want to estimate this because I need to use the points, okay? So having a radical in my answer, so using the exact answer, really won't help me much here. So I'm actually going to take the square root of 40, okay? So what I'm typing into my calculator is 4 plus the square root of 40. I would then hit enter, then hit divide by 4. And I get 4 plus, let's see here, square root of 40. Hit enter before you hit divide, because otherwise you're only going to divide this by 4, and it doesn't work that well, okay? So you'll get an answer, it just won't be the right one, all right? So hit enter after you do your numerator. Then hit divide by 4, and you get approximately, I'm going to round that to 2.6. Okay, so there's one of our x-intercepts. The other one will be 4 minus the square root of 40 over 4. So let's see here. And that gives us approximately -0.6. Okay, so that means that we have x-intercepts at positive 2.6 and negative 0.6. So, let's see here, about there and about there. I don't think I like that. Hold on. Oh, that's because I did that in the wrong spot. Sorry about that. Negative 0.6 is on the other side of 0. I swear I know how to do math, I promise. Okay, so it's about right there. That looks much better. Okay, so now we can actually draw our parabola. There we go. All right, remember, whenever we use the quadratic formula, we're finding where it crosses the x-axis at. So we could, if we wanted to write the order pair, we could write it as 2.6 and 0 and negative 0.6 and 0. All right, so that's it for this problem. All right, I just wanted to remind you that anytime your parabola opens upward, the vertex is your minimum or your lowest possible point, okay? And anytime your parabola opens downward, your vertex is your maximum point or your biggest point, your highest point, okay? Okay, so this is important to know too. The y-coordinate is considered the minimum value if it opens upward. The y-coordinate of the vertex is considered the maximum value if the parabola opens downward. So keep in mind that x isn't really what we're looking for. If I say find the minimum and maximum, what I want you to tell me is what the y-coordinate of the vertex is. All right, so this problem says find the minimum value of the quadratic equation. Now, how do we know that we have a minimum? Well, I know that it opens upward because the number in front of the x squared is a positive 1, okay? So I know that it will open upward. So that means I will have a minimum value because the graph looks like that, okay? So what I'm looking for in this problem is the y-coordinate of the vertex, okay? First, you got to find the x-coordinate, though. So the x-coordinate is negative b over 2a, okay? And so our A is 1, our B is 2, and our C is -8. And so we would have -2 over 2 times 1, which is -2 over 2, which is -1. Now, we have to use that information to get to our y coordinate, okay? So our y coordinate is -1 squared plus 2 times -1. Where did I get that -1 from? From right there. I had to put in my x coordinate, okay? -8. Okay, so we would get +1, because -1 times -1 is +1, -2 minus 8. 1 minus 2 is -1, minus 8. And then we get that y is equal to -9. So our minimum value is -9. Remember, it's the y coordinate of the vertex. All right, so last problem. Let's see here. So it says the quadratic equation h is equal to -16t squared plus our initial velocity times t plus our initial height models the height of a volleyball hit straight upwards with the velocity of 176 feet per second from a height of 4 feet. How many seconds will it take the volleyball to reach its maximum height? Okay, so we have to substitute some things in here, okay? So we're going to use this equation, but we have to substitute in our initial velocity and our initial height, okay? So we've got h is equal to -16t squared plus our initial velocity is 176 t plus our height is 4. Okay, so there's our equation. It says how many seconds, and remember t is our time, it's our seconds, will it take the volleyball to reach its maximum height? That's our y coordinate of our vertex. Okay? All right, let's look for that. But first, we have to find our x coordinate, because remember, this actually says how many seconds will it take the volleyball to reach its maximum height. How many seconds right here is actually our x coordinate of our vertex. Okay? And remember, to find the x coordinate of your vertex, that is -b over 2a. So let's write our a, b, and our c. Our a is -16, our b is 176, and our c is 4. Okay? So part A will give us how many seconds it will take to reach the maximum height, but then part B right here is asking for the maximum height, which is our y coordinate of our vertex. Okay, so we have -176 over 2 times -16. So that's -176 over -32. On my calculator, that's what I'm typing in, -176 divided by -32. And we get 5.5. What does that stand for? That is our x-coordinate of our vertex. So that means this thing, because it's an upside down parabola, it will reach a maximum height at 5.5 seconds. And I don't know what the height is just yet, but I'm going to find that out, okay? So let's take this 5.5, because our part A is 5.5 seconds, okay? Our part B is going to be our y coordinate. So we're going to take 5.5 and we're going to put it into our equation. And I'm just going to type this whole thing into my calculator. So -16, open parenthesis, 5.5, close the parenthesis, hit the square button, plus 176, open parenthesis, 5.5, close parenthesis, and then plus 4. Hit enter. And we get 488. And what does that stand for? That is 488 feet. So that's 5.5 seconds our volleyball will be at 488 feet. That volleyball was hit pretty high. All right, guys, that's it for this video. So hopefully you learned a lot about how to graph and things that we can use in order to graph and make your life a little bit easier whenever you're graphing quadratics. And if you have any questions, don't hesitate to reach out to me. Have a great day.